Welcome to aminacademy.com. In mathematics, let us discuss about conditions for Fourier series expansion. Dirichlet conditions in Fourier transformation are as follows. F of x must absolutely integrable over a period. That means any function must be integrable over a period, then only we can expand as a Fourier series and transformation. F of x must have a finite number of extrema in any given interval. That is, there must be a finite number of maxima and minima in the interval. F of x must have a finite number of discontinuities in any given interval. However, the discontinuity cannot be infinite. Next one, f of x must be bounded by the limits. The last three conditions are satisfied if f is a function of bounded variation over a period. Dirichlet's theorem for one-dimensional Fourier series. We state Dirichlet's theorem assuming f is a periodic function of period 2 pi with Fourier series expansion where an is 1 by 2 pi integral minus pi to pi f of x e power minus inx dx. The analogous statement hold irrespective of what the period of f is or which version of the Fourier expansion is chosen. Dirichlet's theorem. If f satisfies Dirichlet's condition, then for all x, we have that the series obtained by plugging x into a Fourier series is convergent and is given by sigma n equal minus infinity to plus infinity an e power inx equal half of f of x positive plus half of x negative sides. We have the notion f of x positive gives limit f of y tends to x positive. F of x negative is limit f of y tends to x negative. The function satisfying Dirichlet's conditions must have right and left limits at each point of discontinuity, or else the function would need to oscillate at that point, violating the condition on maxima or minima. Note that at any point where f is continuous signal function, that means half of f of x positive plus half of x negative equal to f of x. The Dirichlet's theorem says in particular that the Fourier series for f converges and is equal to f wherever f is continuous. Now Dirichlet conditions further for Fourier expansion is the function in well-defined and single-valued except at finite number of points minus L to L. Next one, the function is with period 2L. That means limits is minus L to L. Therefore, the period of that function is 2L. F of x and f dash of x are piecewise continuous in minus L to L limits. The function has finite number of maximas and minimas. Then the Fourier expansion of the function converges to f of x is a point of continuity and half of x f of x plus 0 plus half of x minus 0 if x is point of discontinuity. Half range Fourier sine or cosine series. A Fourier series with only sine or cosine terms is called half range series. This series is defined in 0 to L to minus L to 0. In such case, we have the Fourier expansion. Now, we'll explain odd or even function. First, what is even function? Now, f of x equal x square plus 1 and the limit minus 1 to 1. Suppose this is a given function, you have to check whether it is even or odd. Now, how to check? So, we have to substitute f of minus x equal minus x square plus 1. We are substituting x as minus, which gives x square plus 1. From this we can say f of minus x equal f of x. So we can say f of x is even. This is a condition, f of x is even. Now further, one more, f of x equal, suppose x cube with the limits in limits minus 1 to 1, suppose. Now we'll check whether it is even or odd function. Now f of minus x equal minus x the cube, which gives minus x cube. From this we can say f of x is not equal to f of minus x. Therefore the function is odd. Function is odd function. In further videos we will discuss about even or odd function, some examples, as well as more examples on Fourier series. We are done. Please subscribe our YouTube channel.